Hey guys, good evening. I hope I'm audible. Apologies for a slight delay, guys, today. Just do let me know if I'm audible as well as visible in the chat. So I'm trying to set up the things here. Cool. So I should be pretty much audible as well as visible. So I welcome you all in today's discussion that is on data analysis in 3 weeks. That's the playlist which we're talking about, and we have started with Seaborn yesterday, right? So our agenda today would be go a bit deep in Seaborn and try to see what are different graphs we can plot, and we'll start with the univariate analysis, and then we'll see what all different good things we have in Seaborn, right? So I'll be taking you over through them. So again, I welcome you all. It's a playlist of data analysis in 3 weeks. And if anybody is having any concerns in regarding Python or for whatsoever topics we have discussed so far, right? It's pretty much a live session, guys. So feel free to put up your question in the chat. I'll try to take them to the best of my knowledge. So let's, as always, as I said, so let's try to make the session as interactive as we can. So that is where we'll both will be having interest, right? So we'll see how it goes. So meanwhile, Vasanta, good evening. Thank you so much for joining us. Hellfire, thank you so much for joining us. So I think people are pretty much joining in. Okay, so again, whosoever started late, so good evening to one and all. It's a data analysis in 3 weeks playlist, and we'll be talking about Seaborn, univariate analysis, and then we'll try to go as deep as possible in the content. Okay. But again, to start with, I'll introduce myself a bit. So you know, my name is Arpit Jain, and I'm a lead data scientist myself. I've been into industry for almost 9 years now, into multiple domains, be it finance, manufacturing, automobile, cloud, telecommunications. I've been into multiple domains, and I've seen how different industry kind of works in data science. So any questions regarding any of the field, any of the data science. I might not be an expert in all the fields, definitely not, but still I do have a fair understanding of how industry works. So any questions, any concerns regarding anything, guys? So do let me know. Even if you're thinking of data science, a future job, and job placement, anything. So please put up your questions. Also, I'm a motivational speaker, so I talk to students regarding their career, job, placements, internships. So please, anything regarding your careers or career-oriented advice as well. So do feel free to put up a question. So I'll try to take that. Cool. So to start with, let me just quickly pull up the content slide. Just a minute. I hope my this is interesting. Just give a minute. I'm again trying to set that. This should be visible. Right. So I hope my screen is visible now. Okay, so yesterday you remember, right? So we were talking about Seaborn. So I showed you what is the difference between Seaborn and Matplotlib. So Seaborn is that I would say an extension on top of Matplotlib, which is where we have a leverage of certain advanced things which we can do in Seaborn. So we have certain benefits over Matplotlib on Seaborn. So the graphs are more I would say smart, more user friendly, and we can fine tune them. So a lot of multiple options available within the graphs. So that's pretty much it. And it works pretty good with the pandas and the NumPy data frame. So that's also something which we have to look forward to. So this is about my Seaborn, okay, and we started discussing on the aesthetics part. So you remember we discussed about two things. We talked about how we can change the style, right? So that's one thing. So plot style. So that's where we saw how we can change the style of my graph. So that is talking about my themes, my axis, my different fonts. So all of those things comes under your styling, the look and feel of your graph, right? So we have multiple themes, colors, and all that. We've already seen it. The second is after style, we have the scale. So we can also scale up my data. So scaling means we have options such as how we can, again, different options are available. So by default, we have notebook, we have what? So we have poster, we have talk. So multiple things are still available within your scaling part as well. So we can also see how we can change the scale of my axes. So that also changes the look and feel of my data. So two different things in styling part, two different things in aesthetics part we saw, style and scale, right? So let me just quickly give you an overview of what we discussed yesterday. So remember we're trying to plot the same graph. So we realized we have two important things which we can do. Just a minute. So we have plot style and then plot scale, right? So plot styles we have set style function, and plot scale we have set scale function. Okay, so set style we have for in this set style we have multiple things available, so we can obviously do a lot of things in this set style. So we can change the theme. We have dark grid, white grid, and all that. We already seen it, so I won't take much time here. And then we can also despine it, so removing the top and the right side axis, which is not getting used for any of my purposeful work. So so this graph is definitely my my y-axis and the x-axis, so we are not using this top and the right lines, right? This is of no use. So eventually that's what we use it for. And then we also use the axis style. So in this axis style we have pretty much other details, so we can change the axis face color, edge color, grid, label color, and text colors, font, right? So all the look and feel part of my data, look and feel part of my graph, that is pretty much available in my axis style. Okay, so we have this available here. So that's what we do in Seaborn. So that's what we have it here. So we can pretty much do everything whatever we want in terms of look and feel changes. And then eventually once we do that, we remember, so we can change the graph, the plot theme, so by giving whatever field we want. And then here in this axis fonts, axis options, we can provide again the option which is available in the list. So if you just simply type the axis style function, right, so it'll give you all the list of available kind of arguments we have to change the graph, right? So it's pretty much still visible. So extreme bottom, so you have all it is pretty much readable, right? So if you go through it, try at your home also, try to make changes in all of these different fonts you have, right? Different options you have, you will see the difference, right? So it's not about learning. Even if I give you a definition of everything, you might still not understand it, right? So it's always good that you try it on your own and see for your own good, like how the graphs are changing, right? So you'll get to know what I'm supposed to do, what I'm not supposed to do, what is making it better, what is making it bad, right? So you'll have that kind of detailing done. Cool. So that's pretty much about it. And the next we have the set context, that is about my scaling job. So second job is my scaling job, right? So in this sets context thing also, we have the good things available. So we have in the set context, we have something called as paper, notebook, talk, and poster. So these are my different scaling elements available. And so how does the scaling work? So you notice, so if the graph is like this, you can see that still the data is between -6 to +6 only, but the ranging is like, the scaling is like 2 interval each. So -6, then -4, then -2, then 0, then so it's an interval of 2, right? But now here you notice, so here again the data is between -6 to 6 only. The data has not changed, so don't think that the data has changed. Data is still the same, but it's just like how to represent the data that has changed, right? So now instead of having that much of granular x and the y labels, I have just made it more generic from -5 to +5, right? So something like that. So that is where we are changing the context or the scaling of my data. We have set the context here, poster, for example. Likewise, I can change it to talk or whatever we have, right? That is pretty much possible. Cool. So that's what we did yesterday, guys. So I told you a lot of things. So I hope this is still pretty much clear with you guys, right? So let's move ahead with this. So the next topic for the day is the color palettes. Color palettes are very important again. So by default, there are certain colors which are getting used in the graph, but again, these I would say color palettes are many a times you still might be needing a different set of colors, right? So so of colors, and then the giving different color combinations is also dependent on the work which you are doing, right? So if you have like what shades to use is like a single shade, and then getting from lighter to darker shades or different colors itself, right? So a lot of different options are still available. So we'll look into all of these. Okay, so I'll just show it to you all of them, and then let's see how we can look forward to. So certain there are readily available color palettes available in Seaborn, so like deep, muted, bright, pastel, dark, colorblind. So these are very standard color palettes available in Seaborn. I'll also show it to you how we're gonna call them, right? So how we're gonna use them is gonna be seaborn.palplot. Okay, so pal is like palette, and then plot is my like basic plot function, right? So we're gonna use seaborn.palplot function, which can be used to give me actually the kind of different palettes we have, right? So for example, see, I have set the color. You can see this here. So this is my color current palette, and what I have done is sb.color palette. So let my Seaborn is sb here. So sb.color palette, I have given the color palette name, and how we can find out the different color palettes available, right? So you can see this. So this is my available list of color palettes I have. You got it? So this is my available list of color palettes I have in Seaborn. It's a pretty intensive list, right? So you have accent, then accent underscore R or accent underscore reverse. Then I have blues, then I have blues underscore R or blues underscore reverse. So for all of these different colors, I'll be having two combinations. A single, the left side, like a general left to right, and then I have the reverse of that color also pretty much available here. Like, so for example, blues and then blues reverse, then BRBG, brown, brown, blue, green, and then we have brown and green, so incoming in reverse. So likewise, so for example, if you want to see, I just want to remove this for now, and then if you want to see how, for example, this BRBG looks like, right? What is this color palette, right? So now we can just simply import it. Just give me a minute, and then we can obviously run this and see this is what my color palette looks like. So this is what my color palette looks like. Okay, and then for example, I want to see grays, right? So grays, for example, let's see how grays looks like. So I have again grays here. Okay, so this is my grays. You can see this shades of grays. So did you notice there are two different generic types of graph? Okay, so two different types of coloring patterns we have. One is more of a sequential data, which is more of greens, blues, grays. So for example, if I give greens here, right? So we have greens, right? It should be somewhere. It should be pretty much somewhere here only. Greens, yeah. So this is one, right? So let me show it to you. So if I do it like greens here, right? So again, you notice it's a shade of green, so lighter to darker, right? So this is a shade of green. But for example, if I give this BRBG, for example, or if I give, say, yellow, orange, brown, so this is also a good one. So if I go this one, right? No, so even magma is still good. Can give magma. Right, so can you notice? So we have different colors here, right? So we're starting from then black, then purple, then again lighter nades. So again, different types of things available we have. So different types of things, right? So there are broadly three different ways in which we can choose the color palette. Okay, so choosing of color palette is also very important. So three different types of objective. One is random. Okay, so default data, which is pretty much random. The second is sequential data. So if you have a sequence of thing which is happening, so like grades A plus, B plus, it's a sequence of objects, sequence of things, right? Then we can use the color palettes like greens, blues, something like that. So it's like a sequence of my colors, right? But again, if I have divergent kind of data, so like for example, I have a neutral, then I have negative, then I have positive, right? Or a zero and then negative and then a positive numbers, or I have say good. Where I have a strict divergence. So for example, for this, left side is different, right side is different. So something of that sort. So two different types of things which we can choose. So likewise, for the sequential data, we can choose the shades of colors like greens, blues and all that. But for the divergent data, we can choose again where we have different colors. So like for example, BRBG could be the one. Right? Cool, makes sense. So this is what different things for now here. And we'll see how we can work on them. Any questions? I think we have one question from Vasanta, and the question is how to know which color are present. Is there any syntax to know the color? That's actually a good question. Let me show you. For example, suppose how to find that. So if I say, for example, magma, right? So suppose if I write say ABCD, okay. So eventually this SB.color, if you write something here, if you won't find out the list here, it will eventually at the end, it will give you this value error, okay? So this value error will be giving you the list of current options you have, okay? Okay, so this is one way, easier way so to find out. So you can obviously find out, this is my supported values. You can see this. So the supported values are within this particular range, right? So this is my available list of color palettes we have. So you can choose obviously in one of them. Got it? So that's one simple way of finding out what all different options are. But again, as I said, so even you have the list of things available here. So again, you have to choose, like, which shade to find out. So this is what I would say, you have to figure out how exactly you can work on these different shades for your own job. Right? So we'll see how to figure out that. We'll see how to figure out. Okay, so now in this same thing, right? So color palette. So in this color palette where we are choosing the right shade for us, we can also specify how many of such shades I want. Okay, we can specify the number there, how many such shades we want. For example, I show it to you. So right now, if I just do a simple plotting here, right? You can see this. So how many shades are there? 1, 2, 3, 4, 5, 6, right? So for example, now if I do it like this, you notice, so by default it was 6. So default is 6 shades. Okay, but we can shades, but again I can obviously specify the number of shades as well. So like for example 9, 11, right? So likewise it'll keep on changing the kind of the color contrast here. So for example, if I give say 11, right? So now did you notice? So the shades still remain the same. So for example, the darkest of brown is this, and the darkest of green is this, and then we have the shades of such things happening. So the shades will keep on increasing. So depth will keep on increasing. So we can obviously change the number of such shades we want in the data. Cool, making sense? Now look at this. So same, now I'm using the same sign plot. Okay, so instead of plotting this data with the default color things which we are getting, right? We are using the color. We are using the option set palette. So we are setting the palette color options here, and we are giving this hustle. Okay, so hustle is the palette we are choosing, and based on this hustle, whatever colors is present in this particular palette options we have is gonna be plotting those colors in my graph. Okay, so we can obviously that's what I said yesterday also, right? So even the colors can be pretty much fine tuned in this depending on your visual appearance. So we can change this this things as well. So pretty much fine. Okay. Cool. So with this, we are pretty much done. We are pretty much done with our aesthetics part. Okay. So again, just to give you a brief layout, aesthetics में क्या importance है? So we have in aesthetics, we have what? So we have a style. Okay. Style, we have in this style we have theme, we have D-spine, and we have axis options, right? And then we have in after style we have scale. So in this scale we have multiple options again here, and then third we have what? So we have color palette. Okay, so this is what aesthetics comprise of. Okay, so these three things are valid for every graph you plot, be it univariate, be it bivariate, be it categorical, be it numerical, any contrast combinations also. So this type of my individual operations on aesthetics is pretty much valid on all of my graphs, whatever you plot, right? So it's not like only for one graph. So this aesthetics is pretty much valid for everything, whatever you plot, right? Now let's start with the actual graphs. Okay, so the first graph in univariate analysis. So as I said, so we'll be starting with univariate today. So univariate is nothing but a single variable plot. I told you, right? So uni means one, variate means variable. Likewise, bivariate means two, and then bi means two, and then variate means variable, right? So univariate means one variable plot, single variable plots. Bivariate means a double variate. So it's like an intersection of my plots, right? So here, the first graph which comes under my univariate analysis is histogram. Okay, the first graph which comes here is histogram. So what is histogram? Histogram represents the data distribution by forming bins along the range of the data, right? And then eventually on top of that, drawing bars to show the number of observations that fall in each bin. Now, what do I mean? So I told you, like, very, very basic definition in this, but what did I mean from it? Okay. So now, for example, suppose that I'm trying to plot the number of people falling in certain age groups, within a society. Okay, so suppose in a society I have say 1,000 people, right? And generally the age is ranging from 0 to 100, right? But again, let's take it from 0 to 120, for example, taking everything in advance. So 0 to 120 is my maximum range, right? Now, what does the definition say? By representing the data distribution by forming the bins, right? So forming the bins. What is my bins? Bins is like a kind of dividing the entire population range of my data. What is my range here? 0 to 120. That is my range. So range is 120 here, right? Maximum minus minimum. So now forming the smaller bins on top of my range, right? So now I have, for example, we can make the range of 10 years. Like for example, I'll make the first bin as 0 to 10. So a group of certain age group, a group of certain ages. So for example, I'll give one first group or first bin as 0 to 10. And then the second group as second bin as 10 to 20, then 20 to 30. So my bin size is 10 here, right? So by a gap of 10, I'm creating different bins here. So I'll be having how many such bins? 12 bins. So because my bin size is 10, right? So and the range is 120. So 120 divided by 10. So I'll be having 12 groups, 12 bins, right? Now what the definition says here, on top of this 12 bins, I'm trying to plot a bar, which is a vertical or horizontal bar also, a kind of a bar, which is giving me to show the number of observations that fall in each bin, right? So now what did I say? So number of observations, right? So now I have 12 bins, 12 bins, right? And when the range is 0 to 1 to 20. So 120 is my range here. So now in a society, if I have say 1,000 people, so out of 1,000 people, maybe 10 or 20 would be between the age 0 to 10, and then 10 to 20 would be say 50, and 10 and then 20 to that, and then 20 to 30 would be still higher, and then 30 to 40 would be the maximum people, and then 30 to 40 will be lesser, and then kind of, so for all of these beans I'm trying to find out how many of such number of observations are falling under each of my such bins, right? And now we'll see how the graph is behaving. So once I have given once I've plotted the number of observations for all of such different bins, right? How my graph looks like. So that is nothing but my histogram. It's giving me the distribution of data falling under the bins by range of the given data depending on the bins which I'm creating. Got it? So that's pretty much my histogram is. So I hope this is pretty much clear. Guys, any questions in understanding what histogram means? Do let me know if this histogram part is not clear to anybody. Guys, just a quick yes or no, guys, if this histogram part is clear to everybody. Right? So, I hope this should be clear, right? There's nothing fancy in that. It's just trying to understand the concept of histogram, right? Okay. So let's proceed. I hope this is pretty much clear with everybody. So now in this, so how to plot this, okay? There are certain hyperparameters, again, parameters available under this. So I won't be going in this right now. I'll be rather showing you the data and then trying to give you the different perceptions of each of them. Okay. Okay, just give me a minute if I'm pretty much looking at the right thing here. Okay. Cool. Thanks so much, guys, for confirming. That's lovely. And then let's see how we can plot this. Just a minute. Great. So now on top of this, look at the data right now. So what I've done is, so as I told, so the Seaborn comes with some default data sets, right? So Iris being one of the prominent such data, which is getting used for all of my initial data analysis work. So I'll show you how Iris data looks like. I'll introduce you to this Iris data, okay? So now what I've done is I have used the available dataset Iris from the SNS library itself, right? So what I've used load underscore dataset, that is my function, and I've passed the dataset which is already available while I've installed Seaborn. So in this Iris, I have 5 columns here. Can you notice I have 5 columns? So I have it's like a kind of a flowers information here. So I have sepal length, sepal width, and I have petal length and petal width. Okay, and then I have certain species of flowers here. Okay, so certain species of flowers, which is a categorical variable here for me. And on top of this certain species, I'm trying to understand how the different 4 parameters of my flowers varies. So sepal length, sepal width, petal length, and petal width varies. Okay, so that's what my objective here is. Cool. Now let's see. So how to plot a histogram here? It's very simple. So it is using a function dist plot. Okay. So I'll be calling the function dist plot, sns dot dist plot. Okay. So here, if you have noticed, we have certain arguments which I can pass. Okay. So data. So the data which I'm supposed to on which I'm supposed to plot the graph, right? And then the number of bins which I want to specify. And then if I won't give it, you get the default value. And then I have the histogram. So whether I want the histogram and then the KD. So histogram and KD, I'll show it to you how does it vary. Okay. So by default here, I have just passed one of the columns. So DF, and then I've passed the sepal length. So for example, I just want to see how the distribution of my sepal length looks like. Plain simple as that. Okay. So once I've run this, okay, I've not loaded this up. So have you noticed? Just set the context. Okay. So does this make sense? So now here what I'm seeing is I have a graph. So in this is my distribution plot. Okay. So this is one of my distribution plot which I wanted to see from the data. Okay. So now here I'm able to see 2 different things. Okay. Can you see this particular rectangular bars here? So I think this is pretty much clearly visible, right? So the rectangular bars. So this rectangular bars we call as the hist. Okay, so in this thing, so the kind of arguments which we pass, so we have called as hist here. So this hist is nothing but my such rectangular available information. So this is my rectangular bars. Okay, so we call this for example here this is for this hist. Okay, and this again a run line kind of showing me a trend of how the data is getting, how the data is behaving, how the data is getting, how the data is distributed kind of a thing. So can you see a kind of a bell curve kind of a thing, or a inverse U, right? So we call this as a bell curve. Okay, this shows that the data is normally distributed. So we have an even spread of data. So it is increased. Initially it was very low, and then it is increasing gradually. In the in middle it is very strong, and then eventually then it is falling. So at the end we have again very lesser data. So it's like a very even trend. Okay, so we call this as more of a even normal distribution. Okay, so now here can you see this? So we have 2 things, hist and KDE. Okay, so hist is for what? So hist is for this. Okay, so this is for my hist. Got it? This is for my hist here. And then I have KDE. So KDE, if I give KDE is true, so by default this line will also come. Okay, so plain simple as that. So for example, if I give now instead of sepal length, I have given the petal length. Okay, so what is petal length? So now the petal length is not giving me a flat or a very clear trend, right? So first it is increasing, then decreasing, then increasing, then decreasing. So it's like a zigzag kind of a curve, right? It's not a very ideal distribution of my data. So we have to see what are things which you can do, right? So we can see in the second bin we have enormous amount of data. Then again it fell down, and then we have again an increase. So it's not a very ideal distribution of data. We'll see that. But again, now how to see the distribution here? So for example, if I put just hist as false, what will happen? So if I give this hist as false, now this rectangular parts, my bars will go off, right? So now my bars will go off. You got it? For the KDE, which is the run chart, so which is giving me the trend here. So if this is still true, I'll still get the run chart. Now if I make this as true and if I make this as false, now I'll only get the bars. I won't get I won't get the line here, right? Make sense, guys? So this is what the basic difference of my different graphs look like. So in univariate analysis, histogram is one of the very most popularly graph used, right? But again, guys, see, there is nothing very fancy in plotting this graph, okay? See, what I did here, I just call this function displot and eventually it has given me this graph, right? I have not done anything fancy here. But the main objective of my being a data scientist or a data analyst here is to read this graph. So now after this plot is there with me, how can I read this information? So how can I find out the right business needed information for my own, for the business benefit, right? So how can I do that? So are you able to understand the difference between these two graphs? I'll just put KD is also true here for now. So my main motto of my work starts here. Can you see the difference in between these two graphs? Can somebody tell me what you see from this? Is this kind of information making sense to you? Guys, quickly, is this information making sense to you? Quickly, guys. I hope you are able to understand this, right? So what we are trying to do here. Quickly, guys, just to let me know if you're able to read up this graph. So the important thing is it's not about plotting whatever things we have. So see, calling the function is still very easy. That's not going to be a very tricky thing. But our main objective here is to understand how to use that information now, right? So after plotting the data, it is important to understand how to read up that graph. That is where the entire game is. Okay, so plotting is not going to create, I mean, a very tricky things for us. It's plotting is still very simple. Okay, but we have to understand how we can change this. I hope it's getting clear for you, right? So we have a question here. Scale is change and easily understand, right? Correct. So, I mean, yes, obviously. So once it depends on how different information we are processing, right? So that is purely dependent on that. Okay. Cool. Great. So let's proceed. So this is what we have majorly for our data analysis in Univariate. So in Univariate, this is what we had as an information. Now let's proceed. So in terms of other information, so how we can actually find out my bivariate analysis, right? So this is what we do generally in Univariate, okay? As simple as that. There's nothing fancy in this. But again, as I said, plotting is not plotting is not all the games. That's not we do and then we just stop, okay? So now after plotting the graph, you have to read it. So that is where, so once you plot as many graphs, you'll be more comfortable, okay? Cool. So let me try to show it to you some other thing. Okay? Cool. Now, what is bivariate analysis? Okay. So bivariate analysis is where we start with the two variable plot. Okay, so we try to see how different two variables are getting plot here. So this majorly deals with the relationship between the two variables and how one variable is behaving with respect to the another. So we are trying to plot the interaction graph between my two variables. Okay, so now here in this data you may have how many columns? So we have 4 numerical columns. So we have the numeric data here, right? And then we have this species column, which is a string kind of a thing, right? So it is more of a categorical data for me. So now I have, just look at this. So I have 4 numeric and then I have 1 categorical, right? Now in this, I can, so if I want to have an interactive study, right? What can I do? I can also plot numeric to numeric interaction, right? For example, sepal length to sepal width, and then I can also see sepal length to petal length, and then I can also see sepal length to petal width. So what is the interaction of between two? So numeric to numeric interaction. I can study this, right? Or also, what can I study? I can also study numeric to categorical, right? So here, for example, sepal length to species. I can try to figure out. So what is my interaction between these two? And also I could also see sepal width between my species. So numeric to categorical interaction. This is also pretty much possible. So yes, so for numeric to numeric, we have certain X, Y, Z graphs. Okay, we'll see that. And then numeric to categorical, again we have certain X, Y, Z graphs. So again, objective is like, it's not actually X, Y, Z, it's like X1, Y1 and Z1 graphs. And then again there will be third study, which is species. So categorical to categorical. So like categorical to categorical, right? So if we have multiple such categorical columns, so we can study those as well, right? So this is majorly 3 type of interaction studies which is possible in my bivariate analysis, right? Pretty much clear. So standardly, this is what we can have. So we can look forward to this. So we can have this, a different type of interactions possible. So during the course of our study, we'll be figuring out how these 3 different interactions are getting plotted and how we can use these information for my study. Okay, so we have this information pretty much available here. Okay, so we'll go into deep one by one. Okay, so let's do one thing. So maybe let me take this one graph and then we'll stop it. Okay, so I won't try to rush into things, so I'll just give you a lot of this. So very first graph which we have in a bivariate is joint plot. Okay, so very first graph is joint plot. It's a very good plot. I'll show you what is the difference here. So just look at this information. Okay, so now here what I'm doing is I'm trying to plot this information, the data here iris, and then in the joint plot we have X and the Y. So in the X I'm passing petal length and Y I'm passing petal width. So it's more of a numeric to numeric interaction for me, right? So here I'm passing for my numeric to numeric interaction. Okay, so now I'm plotting this. So what it is showing me actually. So petal length, x-axis is my petal length. So this is my x-axis petal length, and I have petal width here. So how my data points are getting spread, it's more of a scatter plot for me, right? So we call this as a scatter plot also. This middle part is kind of a scatter plot where I'm plotting on the interaction, like when we are interacting with this petal width and petal length, where exactly my points are lying in the data. Okay, so where exactly my points are lying. Okay, so here this is the entire graph we have, and now the points from my data, this is where all of my points are lying up. Okay, so for example, this point, just look at this central point here. So this means that my petal length is somewhere around 3. Okay, and petal width is somewhere around 1.1 or 1.2. This is what it means. Okay, so this is more of an interaction for me. and likewise how the spread is becoming. So can you see a kind of an upward trend here? So as long as my petal length is increasing, we can say that my petal width is also increasing, right? So for example, if my petal length is 6, yes, I'm also expected that my petal width will also increase, right? So it's more of a very linear trend and an upward trend. Can you see? It's more of a very linear trend. It's going upward in a very I mean it's a trend which we can definitely see. Okay. So in the joint plot we got two things. Central is my scatter plot where we could see the numeric to numeric plot in terms of scatter plot, and on the right side and on the top you're also seeing the univariate of that individual graph. Okay, so for example petal length. So for the petal length, this is how my distribution dist plot looks like, a univariate analysis of my petal length. Likewise, the right side graph is the univariate analysis or the dist plot of petal width. Got it? So that's how my joint plot pretty much works in terms of x and y's in the data. So in the center, we have the scatter plot where the data distribution are being seen. And on the top and the right, we could see the dispersion of my data in terms of the distribution or the univariate analysis. Okay, so that's what my joint plot gives. Clear? So the references, the inferences of my data. So how do I read it? So above figure shows the relationship between the petal length and petal width in this iris data set. Also, a trend in the plot says that a very positive correlation exists between the variables under study. That means that the petal length and the petal width are positively correlated, or in other sense, it means that as long as my petal length increases, my petal width increases. It's a positive correlation, positive impact. So that's what we could see from this graph. Clear? So this is one of the very interesting bivariate analysis which we can do on numeric to numeric interaction, one such type of interaction, right? And we'll see subsequently the different graphs available in bivariate analysis. Cool guys, so with this I'm pretty much done, so I'll stop it for the day. If you guys have any questions regarding any of your things, so just do let me know guys. I hope this session is pretty much making sense. Great. So let's do with this. Let's wind up for the day, and then we're gonna meet tomorrow at the same time, 10 p.m. We're gonna start at 10 p.m. only tomorrow, and then we'll see other different graphs available in Seaborn. Okay, so that will be our agenda for Seaborn bivariate analysis. Cool, guys. Great. Thank you so much, and thank you so much for listening to me. So let's see each other tomorrow, same time, 10 p.m. with bivariate analysis and the graphs. Okay. Thank you so much, guys. Till then, happy learning. See you tomorrow, same time. Bye bye.